have your calculator ready as well. So we're going to start talking about factorial notation. Okay? And when you see a 6 or a number with an exclamation mark, that is something very specific in math. Okay? It's not just a random, like somebody yelling out 6. It is actually, we read it and say that that's 6 factorial. And what that means is that you take the number that is in front of the exclamation mark and you start multiplying it by all the numbers that are lower than it all the way till 1. Okay? So 6 times 5 times 4 times 3 times 2 times 1, then you stop. Okay? That's what 6 factorial means. And it's very, very time consuming to do that. We've done this kind of stuff, right? 10, 9, 8, 7, right? 10. It's very time consuming. And so we're going to do something that makes it a lot faster, especially when you mean to go from the number all the way to 1. So grab your calculators. It's to access the exclamation mark. Maybe you need to have this on your study sheet. We just press alpha window. So alpha window. And then it's option number 9 right here. By the way, 7, 8, and 9. 7, 8, and 9, you're gonna need to use those a lot in this unit and in probability as well. So, but right now we're just gonna access that factorial. So you bring that in, and then you have it on your calculator. I'm not gonna do factorial of my answer. I'm just gonna try maybe 6 factorial. So you just plug in 6. If you don't, let's start this again. Let's go 6. Alpha, window, press 9, and then you get 6 factorial, and if you hit enter, it gives you 720. So that's a quick way to do it. It just makes it a lot faster, okay? So that's that. N factorial, so any number with a factorial means that it's the product of all natural numbers from 1 to n, such that n factorial, this is in general, okay? We can't just use a number. We have to say, in general, if you see n factorial, you start with n, and then you keep multiplying it by a number that's less than n, only natural numbers, right? All the way until you get to 1. So we subtract 1 from the original, then we subtract 2 from the original, then we subtract 3 from the, so it just keeps on going further and further down until you get to the 1. For various reasons, 0 factorial is just 1. I'm saying memorize, but you don't need to memorize because you've got your study sheet, right? You cannot take the factorial of a negative number. Okay, you cannot take the factorial of a negative. It will be undefined. Okay. So for now, let's not just press things on our calculator. Let's actually know what this means. So I don't know why I use 6 again, but here it is. It means 6 times 5 times 4 times all the way to 1, and that is 720. So if it says calculate, it actually wants that number, like what does that amount to? What about this one here? Negative 5 in brackets, factorial, undefined. Can't do it. You can try. I'm going to give this a try real quick here. I'm just going to go 6 factorial, copy that one down. I'm going to try going negative. Oh, it's going to overwrite it, of course. So if you put anything in brackets and then go alpha window 9, it's going to say error, domain, something is wrong, can't do it, right? So can't do negative. What about this one, though? When the negative is outside the bracket, it really means negative 8 factorial. That's really what that is saying. So your answer will be negative. Let's figure out what 8 factorial is. 8 alpha window, press 9. It's 40,320. Okay, so negative is outside the bracket, that's fine. 0 factorial, let's see if you remember that. That's 1. Okay. So that's just it. And so you're soon going to realize that sometimes we have 2 factorials, like one in the numerator, one in the denominator. Okay? I will first, if it says evaluate, like I want you to show work. Okay, it means to show work. We're going to expand and cancel values, okay? So watch what I'm going to do. I'm going to go 8, 7, 6, 5, 4, 3, 2, 1. So you break down the 8 factorial. At the bottom you have 6 factorial, so that's 6, 5, 4, 3, 2, 1. Everything is multiplying in the numerator. Everything is multiplying in the denominator, which gets you to do the funnest thing ever probably in math, which is cancel. Okay, cancel things out. So you can kind of see that this is going to cancel. That's going to cancel. Which really leaves you with 8 times 7, which is 56. And if you don't believe me, you can quickly do this yourselves, right? 8 factorial divided by 6 factorial. I just go alpha window 9, right? Yeah. Oh, it's 8 times 7, sorry, but it is still 56. Thank you. 8 times 7, 56. Okay, so you can practice that. And why am I showing you this? Because there are times the calculator cannot do it. When the numbers get really big, you have to do this. You have to break it down, and then you'll find out the answer. So let's do this one here. 7, 6, 5, 4, 3. Watch what I'm going to do here. Instead of going 3, 2, 1, and so forth, I'm just going to say 3 factorial. Why? What do I see in the denominator? I see a 3 factorial, right? What do we technically know when there's a 3 factorial? How does the story end? What comes after the 3 technically? Times 2 times 1. What's going to happen to the bottom? It's going to be the same. 3 times 2 times 1. So instead of writing that all out, I will just cancel them out there already. Like, why bother writing out the whole thing? Okay. So that's 7 times 6 times 5 times 4. That's 840 is your answer there. I'm going to skip this one because it's the same idea here. This is the one. Can you try doing this with your calculator? 100 factorial divided by 97 factorial. Try typing that in. Error? Yeah. So this was on an exam before. They're like, hey, evaluate this. And students were like, just typing it in. There was a time that I didn't emphasize this enough. Now I'm emphasizing it, making sure you know. So they're going to expect you to break this down. So I will make a note. Note, calculator gives error, right? Breakdown, right? So I'm going to make an arrow to that expression so you know that's the one I'm talking about. So all you need to do here is go, what's 100? It's going to be 100 times 1 less than that is 99. 2 less than that is 98. 3 less than that is 97. And then I'm just going to say stop, right? Because I see a 97 factorial. Just make sure you don't mix up. If there's only 97 down here, okay, it's not the same as 97 factorial. So don't be canceling 97 factorial with just 97. It's not the same, okay? So watch out for that. So 97 factorial is there. Perfect. I get to cancel this out. And so now I'm left with 100 times 99 times 98, which is 970,200. Okay, so it can be done. Our calculator just can't help us there. This one I just found interesting. I just threw this in the booklet. What's 4 times 3 factorial really? Well, let's see. 4, right? Times, what's 3 factorial? 3 times 2 times 1. What does this look like if you zoom out? Isn't this the same as 4 factorial? Yeah. And 4 factorial is 4 times 3, that's 12. Right? Times 2 is 24. I'm going to ask you to add this to your study sheet because it's very tedious to always type this in the calculator. So I'm just going to say, if you have room, I would say figure out what 8 factorial, 7 factorial, 6, figure out what these are, and it just makes your job so much easier. 1 factorial, that's just 1, right? I'll still put that in there. So I'm just going to give you the answer. So 8 factorial is 40,320. 7 factorial is 5,040. 720 for 6 factorial, 120. And that's 24. 6, 2. 1 factorial is just 1. And 0 factorial is also 1. Make it a lot smaller than this. I'm just making sure you're able to see this. Because you're going to see these numbers over and over again. You're going to see a 6 factorial. And then you just know, you go to your study sheet, oh, that's 720. Boom, here it is. I need to multiply 720 by something else, right? And so it's just going to be a lot quicker to just get it. Don't memorize it because sometimes students think they will memorize it, then they're off. Like the difference between 7 factorial and 8 factorial is significant, right? It's significant. So keep that in mind. Let's go to 14. What about this one? Lots of stuff going on, right? I will do this. I will start with I always start to break down the largest one first, okay guys? So 17, 16, 15, 14, and then I stop because I see a 14 factorial down in the denominator. What about the 3 factorial? I'm going to write it out. 3 times 2 times 1 times 14 factorial. So basically your idea is like get rid of the factorials. That's the idea here. Cancel out the 14 factorials there. And so that's what I'm going to just say, get rid of factorials, right? Okay, make sure, maybe add a little note. The idea is getting rid of it. So 17 times 16, that is, I have the final answer, which doesn't help in this case. It's 4,080, and this bottom one is 6. If you divide that, you get 680. You want to try this one real quick? Quick, fast. You guys remember those days? Oops. $220 is what you're supposed to get. And this is as a warm-up for this next concept here. Okay, we're going to start with permutations. In math, often teachers call this perms, okay? Perms, and then the next word later on next week is going to be combs, okay? Perms and combinations, permutations and combinations. We're going to start with where all the objects that are present are distinguishable and they're unique, okay? NPR, if you see NPR, is the notation used to represent the number of permutations or combinations that can be made from a set of n different objects. Okay, you've got n different objects, and you only have, let me use orange here, you only have R number of objects that are being used in the arrangement. Okay. And notice that R needs to be between 0 and n. Here's your formula, okay? And you're going to see where this goes in a bit, okay? So for now, just make sure you have this formula on your study sheet, okay? This is a must. NPR, so what we will do is, if you see a number, P, and then another number, we will substitute n up top with a factorial, and in the denominator, we're going to go n minus r. You're going to subtract these two and make sure you put a factorial to that. So let's see what pattern we observe. It's going to save us some time. So if you see 5p2, it just means 5 factorial over 5 minus 2 factorial. And that's really 5 factorial over 3 factorial, if you simplify that. And then you go 5, 4, 3 factorial. I stopped there because the idea is to simplify this. You're left with the 3 factorials, which we cancel out. So what are you really left with? 5 times 4, right? 5 times 4 is 20. What about 100 pick 2? Sometimes we use pick as well or a permutation 100 P2. That'd be 100 at the top, and then it's 100 minus 2 factorial at the bottom denominator. So that is 100 factorial over 98 factorial. Okay, so we gotta break this down. So it'd be 100 times 99 times 98 factorial, and in the denominator you have 98 factorial as well. So we get to cancel those out. So this ends up being 100 times 99, which is 9,900. Five pick 5. You start with 5 factorial. In the denominator, you've got 5. I'm just following this formula, right? 5 minus 5 factorial. That'd be 5 factorial over 0 factorial. What's 0 factorial again? Just 1, right? So it's just 5 factorial, really. Make sure you write, I'm trying to show you a pattern. It's 5 times 4 times 3 times 2 times 1. What's 5 factorial? We have it right next to in our previous page. It's 120, right? Six pick 1. That'd be 6 factorial over 6 minus 1 factorial. 6 factorial over 5 factorial. Let's simplify this. It would be 6 times 5. I'm not going to keep going because I see a factorial in the denominator. Cancel that out. So this is really just 6, right? Let's see if we can add some context to this. What kind of story could we have said? Let's put slots under these here. Let's say this could have been a story like, how many ways can the first and second place be awarded to people, right? If there's 5 participants there, right? Using the fundamental counting principle, we would have gone 5 times 4. So, right, you've got five people and 2 awards need to be given. Or you've got 5 people and there are 5 awards to be given to everyone. However, when things decrease like this, what do you know about, like, if you think of today's AC or the group work, what does that mean if it drops? What kind of wording is associated with something? No repeats, yeah, and some of you whispered it or you told, yeah. So no repeats. So permutation is perfect when there's no repeats, okay? Oh, I kind of gave it away. I added this just this year. My original doesn't have that. But I would like this to be a different color. Like, grab a color that you haven't used yet. When you use permutations, we are going to assume that we can't repeat, right? We can't use the same. So that's something to note. So let's go to 15 here. So everything we've been doing so far, guys, it doesn't go anywhere. It's just that now we might use permutation to make it faster. Okay, guys, this is another tool. But if you want to stick with what you've been doing so far, just do it. We have 16 billiard balls. That's like pool balls, right? If you play pool. What is the number of possible ways to pick 3 balls without replacing the balls? Okay, you're not putting them back. So using the fundamental counting principle, if you're choosing 3, right? This is ball number 1, ball 2, and ball 3. There's 3 events that we're talking about. And since we're not replacing them, we start with 16, then it's 15, then it's 14, right? And what is that? I don't have the number in front of me right now. That is 3,360 ways that you could select. Okay. So that's a fundamental counting principle that we've used here. Factorial notation, guys. We're going to do it a little differently. Out of the 16 balls that we've picked, that we have available, how many are we picking? 3, right? And so how does this go? 16 factorial over 16 minus 3 factorial. That'll be 16 factorial over 13 factorial, right? That's the factorial notation, okay? Basically, if it ever asks you what's the factorial notation, it is basically you using the formula for permutation, right? You say, oh, it's 16, pick 3 here, of course. Plug it into the formula, get it to this right there. That's the factorial notation. I will not give you marks for it. I will not say, hey, you must do it this way, but the homework asks for it sometimes. Let's simplify this even further. 16, 15, 14, 13 factorial over 13 factorial. Cancel that out. Doesn't it look exactly the same as the previous? Right? So it's just a faster way of doing it. And so this is 3,360 ways. I want you to use the calculator now, though, to do this. How do we enter this into our calculator? Press 16, alpha window, and you should see permutations. That's our 7th option there. Hit enter, and then you pick 3. And you get the same answer. Okay, so that's much faster, I think. If I don't ask you to evaluate or anything like that, just give me the final answer. I don't care about everything in between. I just want you to understand that it's all connected. Okay? So, calculator, right? You press 16, and then it's alpha, window, 7, and then you press 3, okay? Then it should say 16 pick 3, which is 3,360. So if you need to use your calculator, by all means, you do that. Guys, I'm not teaching you anything new. I'm just teaching you, well, maybe I'm presenting it differently, but we're still doing the same thing as before, using the fundamental counting principle. I personally will use this a lot more than this, but they are doing the exact same thing, and you must know that that is the case, okay? What about the next one here? There are 6 people running for president and vice president. How many winning combinations, assuming that the top 2 win the spot? Fundamental counting principle would say, well, there's 2 spots. There's president and there's the vice president. And you've got 6 people that are running for it. So technically you have 6 options for the first one. Let me ask you this. Do you think repetition is allowed or not allowed in this context? Not allowed, right? Because president is the president, right? And you can't have the president being the vice president as well. So that's 6 times 5. So there's 30 ways. Factorial notation, Fn. Please just use this one. We're just going to say there are 6 people, and we're choosing to fill in 2 positions. So out of the 6, we need to pick 2 at a time, right? 6 pick 2. So that is what? That's going to be 30, right? By the way, see this pattern? How many are we picking? 2, right? So the short version is start with n and then pick 2, like 2 numbers. Starting from 6, it's only the first 2 that are going to remain if you do the factorial. So that's 30. If it had said 6 pick 3, then it would be 6, 5, 4. You're doing the first 3 countdown, right? So that's how that goes. I'm gonna stop here. Yeah, I'll stop here. I'm gonna ask you to try 15, 16. There's not a whole lot there, and page 20. Okay, so I'm going to say homework. Page 15 to 16, which is not a whole lot, and page 20. You have to try this, guys. You have to read. You have to come across scenarios that you're not so sure about, and try these questions, okay? There's no other way. So maybe do a few before you go. I'll post a key